Performance is an important topic for any app developer. For mobile app developers, it's an essential topic. The apps we produce have to run well to live up to the expectations of our users, avoiding those dreaded bad app store reviews, and make the most of the resources of the devices upon which they run. So let's look at the issues that can affect performance and talk about improving app performance. First of all, we have memory issues. We have to remember that iPhones are phones, and despite the huge advances that have been made over the years, they still have only a certain amount of limited memory available. So iOS has priorities. It'll try to give the running app as much memory as it needs without jeopardizing system stability, i.e. keeping basic phone functionality, for example, and maintaining multitasking functionality. It'll keep as many suspended apps as possible in memory to support multitasking, and it'll give the foreground application as much memory as possible. iOS 5 has been improved over iOS 4, but we still have to be concerned about memory issues. If things start to go wrong, if memory starts to get full, iOS will start killing off suspended apps. Virtual memory will be freed up. Code pages will be evicted. That means that code pages containing code for your app could no longer be in virtual memory, and when you need it again, it'll have to be loaded again, and that's going to hit performance. And eventually the foreground app will be terminated. Now, how do you know if your app's in danger of being terminated? Well, iOS 5 issues fewer memory warnings than iOS 4 did. But when you get a warning, it means that the suspended apps have already been terminated. It's a last chance. So it's not really a warning. Memory warnings should really be called memory critical alerts. There is an iOS system component called Jetsam, which controls all of this, and as soon as you get a memory warning, you should act. Don't prompt the user to close other applications, because the user can't do anything about it. And don't ignore the warning and carry on just hoping it'll go away, because your app will be closed without further warning. So act immediately. How do you know you've got a warning? Well, in your app delegate, you will receive a warning, and in the application did receive memory warning method, you can pick up that warning and you can act upon it. If you receive a memory warning, free as much memory as you can by releasing or purging any data that can be reloaded from disk later, and save any settings that are necessary, save any state settings that are necessary very quickly. You can also detect warnings in UEView controller subclasses. Now, given that UEView controllers are where most of your logic is probably happening, it's good to be able to detect a memory warning there as well. And we have the did receive memory warning method, which will allow you to pick up a memory warning to release any cache data, as before, but also to release any images that your view controller may be holding onto, or any views that you may not need at the moment. Anything you're not using. You can also subscribe to and receive the UE application did receive memory warning notification. How do we do that? We'll add an observer, define a selector, and we will pick up the UE application did receive memory warning notification from the system, should it happen, and when we pick that up, we can actually start to act on that as well. Now, ideally, we should reduce memory usage in the first place and not get ourselves into the problem where we'll get a memory warning. So preempt the worst. Free up any resources when you're suspending. In the app delegate, you can basically, in the application did enter background method, you can free up resources that are not needed. Suspended applications don't receive memory warnings. So as soon as your application enters background, free up anything you don't need, especially if you want your application to be able to stay in the background, to be started again quickly if the user comes back to it via multitasking, or simply to monitor location changes, for example. Keep it light. Heavy apps will be cancelled while suspended, but there's some good news. The less memory your application needs, the more likely it is to survive the culling operation that happens when memory resources get low. There's a 16 megabyte ceiling, above which your application is pretty much guaranteed to be culled, and below which you've got a much better chance of having your application staying in the suspended apps queue. So keep your app below this, your app will stay suspended longer, and you've got more chance of it still being there when the user wants to come back to it. Now, what other ways can we do to ensure that the performance of our application is optimal? Keep your code clean. Not only is clean code easier to maintain, but you keep it clean, tidy and light, and it will be easier to follow what's happening, easier for you to spot potential issues with memory management. If you have not changed to using ARC, then follow a simple rule. If you allocate something, free it, deallocate. Be methodical. Only do what you need to do when it's needed. So don't try to do all of the data loading and everything all at once just because it's easy. Do it only when it's needed. And test and refine your application. Use structured testing approaches, followed by code changes and retest. And test individual changes and individual areas of functionality, individual cases, one at a time. If you test and change too many things, you won't know what's happened to make something run better or run worse. Prioritize. Get the app started, get it up and running, and the user will see something happening, and the app is there on their phone, ready for them to use. Load large amounts of data in the background, and show loading and activity indicators to give the user feedback of what's happening. Keep the app responsive. It's all about perceived responsiveness. There is an iOS watchdog which will be watching your app's performance. It watches your startup time with a maximum of around 20 seconds. So if your application is taking more than 20 seconds to start in the simulator, it's not even going to start properly on a device. Suspend and resume times and times to perform an operation are all watched to be under around 10 seconds. If your application gets groggy and is performing too slowly, it's likely to be aborted. And quitting your application also should take a maximum of 6 seconds. Now, none of these numbers mean that it's perfectly okay for your app to take that long to start up or to perform an operation. I would say that if an application is taking 20 seconds to start up, then the user's going to think it's broken and be pretty unimpressed to start with anyway. So we need to test. We need to test for the startup times, we need to test performance. We should test in the simulator, and we should check with instruments. We should test on devices, and cross-check with instruments again. And we should test on the slowest device supported. If your application should run on a 3GS, then test on one. And use cases. Use cases are important. Use the application, use it, see how it works, feel how it works, use it as you expect a user to use it. If it seems slow, then it is. In both cases, not only test with realistic use cases, but test with realistic data, with the quantity of data that you expect the app to use in normal life, and a diversity of data. And diversity is particularly important when you're testing with MapKit. Location data should be as diverse as likely to be found in the real data, so as to test dequeuing routines and filtering routines, etc. How should you test and trace what's happening in your applications? Well, obviously there should be logging in place. And you can use NSLog quite cleverly with timers to see how long things have really taken to run. You can also use NSLog, obviously, to just check variable content, but not only variable content, just check how many times you're going into loops and into areas of code. You may be surprised that loops are performing more than they need to, or that functions are being called when they're not even necessary. Instruments is a great tool, particularly the allocations instrument and the leaks instrument. Allocations will show you all abandoned memory that can't be accessed again. And leaks will show you objects that are not released, for example. Now, if you're still using retain release programming, you need to check the matching or to make sure that original values of variables have been released. running quickly through the leaks instrument will show you if you do have any leaks and give you some clues as to where your code may be going wrong. Now I've got a project here which needs a lot of performance tuning, not only to test for leaks and what have you, but I'll show you quickly how you can run it through instruments to check for leaks. So here we are in Xcode. Here's the project open. It's doing a lot with MapKit, it's doing a lot with data access, it's starting slowly, but I'm going to click here and choose Profile. And I'm going to open the Leaks tool and profile it. It's going to start running in the simulator, it's going to start up. See quite a few allocations happening there. It's taking a long time to start, and straight away I can see I've got some leaks here. This is not looking good at all. And I know that when I start to use this application and I start to move around, it's gone. The responsiveness is gone. It's completely locked up. This is just not the way it should work. It's terrible. So let's just kill it. And let's not even look at it anymore. Let's take a little look at what instruments can tell us here. Now, this doesn't look good. If we look at these leaks here, we can already see straight away what's happening and where something's happening. I can, if I want to, I can view extended details. I can look at the whole stack trace, what's been going on. I can just double click on here and it'll take me straight through to the code, and it's showing me here I've got an initialization of an NS mutable array. Now I know from looking before, go back here, my leaked object is the NS mutable array. We can have a look here and rather cleverly, for the sake of this demonstration, I'd commented out the release code. Now this project has not been converted to ARC. I think that's probably one of the things I should do to save myself the headache of having to remember to release objects. But I can see I've probably got quite a few other issues I need to look at, and quite a few sessions with instruments to trace what's going on in this application and tidy things up. So you see how dangerous retain-release programming is. Something else that's also dangerous is auto-release. It's a standard safety belt for a lot of us, but it has hidden dangers and it basically should not be used. It's not a quick fix for memory issues. It puts the responsibility of release on the framework, uses the framework auto-release pool, so whichever framework you're referring to and using has got to deal with the whole release pool. It can cause a memory spike because objects allocated within the auto-release pool may well build up and probably will build up as your application runs. And they won't be released until you release the whole framework. Now, we shouldn't be using auto-release. We should move to automatic reference counting in iOS 5, and we'll find that a lot of these problems will be solved. We'll also find a lot of the issues that you saw in the short demonstration with retain-release programming will be solved, and generally a combination of moving to automatic reference counting, to keeping code clean, to being aware of the resource issues that we're dealing with, and testing and retesting and constantly tuning, we should find that we can really improve the performance of our applications and deliver the kind of experience that we ourselves would expect as users of our applications.